Longtime followers may know that my initial goal when learning ComfyUI was to recreate dance videos of girls. Back then, the solution involved frame-by-frame decomposition, pre-processing pose and depth control conditions, then using AnimateDiff and ControlNet to generate each frame for a new video, such an incredibly complex process. Since then, newer models and solutions have emerged, delivering increasingly high-quality results. Today, I'm introducing Wan2.2 Animate, which I believe currently offers the most natural-looking results. Here's a simple description of its functionality. Given a character image and an action video, it enables the character to mimic the movements in the video, or even replace the original character in the video with your chosen character. Wan2.2 Animate was officially released by the Wan2.2 team from Alibaba Tongyi Wanxiong. The original model comes in BF16 format, with a file size of 34.5 GB, but can run directly on a GPU with 24 GB VRAM. KJ has converted the model to FP8 format, shrinking the file size to 18.4 GB. In ComfyUI, cards with 16 GB VRAM run smoothly with this version. Note: for 30 series and older GPUs, select the E5M2 variant. For 40 series and newer, use E4M3FN. There's also a GGUF version, but in my experience, the Q8 model is less stable than FP8, especially when generating 720p motion transfer videos. Performance is significantly lower. If you're on a 16 GB RAM GPU, FP8 is optimal. For even lower VRAM, GUF Q6 and Q4 are viable options. After downloading all models, place them in the models/diffusion_models directory. For clip, use the Wan Series Universal UMT5 in either BF16 or FP8 format. Place it in the models/text_encoders directory. One important note: KJ's wrapper cannot use the FP8_scaled format converted via ComfyOrg. So there are two different versions, please select accordingly. To accurately extract the visual features, identity, style, from the reference image for guiding video generation, you'll also need the clip-vth/14 vision encoder, specifically, clip_vision_h. We've used this since the IP adapter era, so check if it's available in models/clip_vision. This model still uses Wan2.1's VAE. Among all released Wan2.2 models, only the 5B model uses the new version of Wan2.2 VAE. If you select the wrong version, you'll encounter errors. Let's get started. Make sure to upgrade your ComfyUI version to at least 0.3.60. Then install these plugins. ControlNet Preprocessor, the all-in-one KJ Nodes toolbox, Video Helper for video loading and composition, and Segment Anything 2 for video segmentation. You don't need to install anything else separately. If you drag a plugin node into your workflow, the manager will prompt you for installation if necessary. After ComfyUI officially supported the Wan2.2 Animate model, a corresponding workflow was added to the template library. However, this workflow is exceptionally complex. Since Animate requires data that's hard to obtain via native nodes, this workflow uniquely incorporates third-party KJ nodes, using many get and set operations, which complicates explanation. Additionally, it doesn't separate the two distinct functionalities of motion transfer and character replacement, nor does its video processing handle advanced scenarios. Consider this workflow a starting point. For demonstration, I'll use my own modified workflow as the basis. Before utilizing a model effectively, it's important to understand its requirements. Let's take a look at the core node inputs. Beyond the usual prompts and VAE input, it needs a reference image and the embedding vector generated from it via a visual encoder. A face video. In native ComfyUI workflows, this is typically a facial skeleton map from MimicMotion, while KJ's Wan video wrapper uses the segmented face video. For character replacement, using the actual face video better captures expressions and lip movement. I'll be showing the comparison during the demonstration. A pose video. This is the skeleton map from the reference video, generated with the ControlNet preprocessor, similar to the method used with AnimateDiff in the ancient times. For character replacement, two additional inputs are needed, a background video and a character mask. Unlike standard cutout masks, this model requires a mosaic-style mask, which helps generate more natural results and greatly reduces artifacts during compositing. With so many different inputs, it may seem overwhelming. But don't worry, we'll walk through a dedicated video material production workflow. There are two main approaches for material production. Both the native workflow and the original Wan video wrapper used this solution. I've disabled other nodes to show this core process. The core node is points editor. Use green circles to define the subject, the part to keep, and red circles to define the background, the part to discard. Pass these annotations to SAM2, segment anything to, which interprets them and automatically tracks and propagates segmentation across subsequent frames, intelligently adapting to subject movement, pose changes, and occlusion, resulting in accurate character cutouts throughout the entire video. Click Run once to bring up the first frame. By default, you'll see one green and one red circle. A green circle tells the model the content you want to keep, while a red circle identifies content to be discarded. Hold Shift and left-click to add new green circles. Typically 4 green circles provide reliable person annotation. If you add the wrong circle, simply right-click the circle to remove it. Hold Shift and right-click to add new red circles. I usually mark 4 red circles. Enable the subsequent nodes in Approach 1 and run them. The mask will be displayed as a somewhat abstract blocky dance video. This is because the fine character mask is first processed into a blocky, mosaic, form. By overlaying the blocky mask on the original image, you can visually see the masked area. Compared to using the original fine mask, a blocky mask helps the model generate more natural results and significantly reduces compositing artifacts. You can adjust the Blockify mask node parameters to change the block size, balancing mask smoothness and detail, but it's best not to go below 32. The following nodes generate the pose, skeleton map, video and face video, which are required by Wan2.2 Animate for sampling. Native workflows need these as well. In the DW Pose Estimator node, always select body, hand is optional, and face isn't necessary since the node for acquiring the face mask doesn't rely on DuPose face detection. Now let's review Approach 2. This is KJ's latest approach. It detects the pose to define the person's location, then passes this to segment anything to generate the mask and other content. This works fairly well for single-person videos. However, increased automation leads to reduced flexibility. In complex scenarios, it's less stable, cannot handle multi-person scenes, and still has plenty of room for optimization. After understanding the required inputs for the model, we can better grasp the workflow. Let's start with character replacement. The node group on the far left of this workflow is used to upload the video and reference images. The dimensions we've set are 720 by 1280 for portrait videos. If you want to process 480p video, you can change this to 480 by 832. Make sure the subject in the input video isn't too obscured, and the duration isn't too short, ideally, more than 33 frames. You can control which segment of the video to use by adjusting the frame skip and frame count. The character image should roughly match the pose of the character in the first frame of the video, e.g. both facing forward or sideways. If you require higher quality, you can use context to transform the input image into a style similar to the video's first frame. Pay attention to the Resize Image v2 node. We need to convert the reference image to match the size of the driving video, but we definitely don't want to squish or stretch the subject. Therefore, we use edge pixel padding to maintain aspect ratio. This option isn't commonly used in other workflows, as it technically alters the original image. However, for character replacement, as long as it doesn't affect the character itself, it's perfectly fine. We just covered the material extraction section. Here is a more robust option A. As before, first disable the downstream nodes and annotate the character and background in the first frame. Then, enable all other nodes. Pose and facial asset extraction is the same. I mistakenly called it background here. Let me correct that. The bottom section is model loading, with many nodes. Let's go through them one by one. For the Animate model, I recommend using FP8. It is much more stable with longer frame counts compared to GovQ8 and works on my local machine with 16 GB VRAM. Usually, we also use LoRA to accelerate and improve quality. For acceleration, use Wan2.2's or Wan2.1's Lighting X LoRA. The effect is similar. For quality LoRA, relighting is the official release and helps blend the replaced character better with the original video background. The community is continuously releasing new ones, so feel free to try those that suit your output. The model sampling SD3 node controls shift, set it to 8 if using the acceleration model, otherwise keep it aligned with the official code and set it to 5. If VRAM usage is heavy, you can add the block swap node, which dynamically swaps some transformer blocks between CPU and GPU. Usually, set this between 25 to 40. A higher value reduces VRAM requirements but slows inference, assuming VRAM isn't maxed out. Note that only nodes from this plugin are compatible with the native workflow. Nodes inside Wan Video Wrapper can only be used with that wrapper's model loading nodes. Prompt words can be in either Chinese or English. Since this workflow has many control signals, including character and background, simple positive prompt words suffice, though you can add phrases related to lighting or atmosphere as well. Negative prompt words are generally left unchanged. CFG is set to 1, which typically doesn't have much effect. Nothing else to mention here. The final area is sampling. First is the core node Wan Animate to Video. Connect all the prepared media assets to it. Batch generate number determines how many clips are generated per run. It significantly increases VRAM consumption and can easily cause out-of-memory errors. Continue motion and video frame offset are used for stitching longer videos, which I'll cover shortly. Lastly, the sampler. If using acceleration LoRA, you only need 6 or 8 steps, otherwise, run 20 steps. Keep CFG at 1. For the sampling method, the native workflow uses Euler plus simple by default. Wan Video Wrapper uses DPMPP SDE. Wan2.2 official inference code uses DPMPP. I've tested them all and there's not much difference. So just stick with Euler plus simple for simplicity. Here, we merge and compare the original and new videos. Click Run. On a 4090 it usually takes about 4 minutes. Check the results, everything works fine. The Catwoman character perfectly replaces the original girl. Her feet look a bit red because in the first frame, there wasn't a shoe to select when annotating. Previously, I mentioned that in ComfyUI template workflows, a face skeletal map is used instead of a face image. Let's compare that. Add a DW pose node to detect the face separately, duplicate a set of sampling nodes, and add another video to the final comparison result. Click Run. I think the difference is quite obvious. After using a face image, the facial expressions are noticeably more vivid. Now, let's switch to a multi-person video and see how to replace only a specified individual. Again, disable all other nodes and start annotating. Set the girl on the left as the replacement template, and use red to mark the girl on the right and the background. Segment anything 2 handles multiple subjects just fine, but the subsequent pose and face detection nodes might not ensure we're targeting the right character. So, we need to add a draw mask on image node. Apply the inverted mask to the original video and get a video containing only the girl to be replaced. Feed this video into the pose and face processing nodes. Now it's foolproof. Click Run. You'll see that face detection picks up only the selected girl. Enable all nodes and run. The effect is perfect. The final flicker is because the original video's girl on the right changed outfits. The Wan Animate model supports seamless continuity by feeding the end of the previous video segment into the next round of sampling. Load up the workflow. This one continuously generates 2 segments, each 77 frames long. Its core is similar to the previous workflow, except it adds another Wan Animate to Video and sampling node, utilizing the perms we just skipped. The second sampling phase requires the video frame offset from the first sampling. Pay close attention to the calculations here. In the first round of sampling, we generate a 77-frame video. In the second, it references the first 5 frames, so only 72 are new in the second segment. When finally stitching the new video, be sure not to double add those 5 frames. Click Run. This is shown here as a demo, so only 2 rounds are run. If you need longer sequences, you can add more rounds yourself or use a for loop node to cycle. Just make sure to avoid repeating frames between segments each time. 2 segments of 77-frame, 720p video took a total of 11 minutes. Consistency is excellent, though near the end of the second segment there's a black artifact beside the character's leg. I think that relates to the mask shape, but it's a rare glitch and the model usually handles it well. I changed the seed for the second sampling to random and ran the second round again. Waited another 5 minutes, and sure enough, no issues this time. Another core function of Wan Animate is motion transfer. Unlike character replacement, which swaps the character from the reference image into the driving video, motion transfer syncs the movement from the driving video to the reference image. No background video or character mask is needed, making usage much simpler. Motion transfer has lower requirements for the reference character. I used a 3D anime avatar with exaggerated large eyes. Be sure to set the resize node to crop from the bottom. This differs from character replacement. I'll disable the other nodes to show you. If you still use edge pixel padding, you'll clearly see pixel bands at the image edges. If you don't want to stretch the image, try various crop settings. Cropping the top will cut off the girl's feet. Bottom cropping only removes a bit of sky, which is hardly noticeable. Enable the other nodes. For these anime-style inputs, I recommend using a face skeletal map. Not supplying one or uploading a face image yields unstable results. By the way, wrapper workflows are implemented differently. Over there, best not to upload a face image. The other input and sampling parameters are much the same as for character replacement. Click Run. The result is excellent. The anime character's movements are correct, and her skirt's motion is natural and elegant. I find Animate's motion transfer very reliable. Let's test a different video, this time only 33 frames. Click Run and wait patiently. It just occurred to me, I haven't changed my positive prompt words, they're still dancing. But that's fine. Like I mentioned before, prompt words, especially those related to motion, have little effect on video output. The results are in, and just as expected, the movements are almost identical. The young lady elegantly walks forward, and perhaps picking up her skirt is her effort to match the dancing described in the prompt. Sometimes, we want to batch process different characters to imitate the same action from a video, but the current workflow requires processing the driving video every single time, which isn't really ideal. Earlier in the video, we introduced a workflow that converts the driving video into reusable assets for future use. So, how do we actually use those saved assets? Taking this video as an example, we can simply right-click to save the pose and face videos directly. They'll automatically download to your local device. Next, add 2 upload video nodes, upload the downloaded videos, and swap out the previous connections so they feed into the Wan Animate to Video node. Click Run. And there you have it, the results are excellent, just as expected. This means you can reuse one set of assets for many different characters. Motion transfer also supports video extension, and the character replacement workflow is almost identical. Both involve multiple sampling passes, with each output containing 5 repeated frames. Just be mindful to merge these appropriately. I won't go into further detail, I'll just run it and let you see the results directly. After a long wait, we ended up with a great result. The young lady's subject 3 dance came out quite nicely, right? Before ComfyUI's native support, I always used the wrapper workflow. Its advantages include support for frame window size, context window, automatically segmenting your input video for processing based on its length. So you don't need to manually handle video extension. It's also compatible with various model compile options for faster performance. For motion transfer, wrapper is more stable overall. However, as it's continuously updated, it supports many new features but requires more user expertise and has a steeper learning curve. Now that there's native support, I won't cover the wrapper workflow separately, but I'll still share it for those interested. Alright, that concludes the demonstration portion. Let's summarize. Wan2.2 Animate provides 2 main functions, motion transfer and character replacement. While other models, like VACE, can achieve similar results, Wan2.2 Animate offers significant optimizations in these areas. It's the best I've used so far, and it also supports a video extension feature for generating longer videos. There are some drawbacks. The workflow is complex, the model size is large, runtime speed is slow, and it's incompatible with most Wan 2.2 LoRa versions. However, if you need motion transfer or character replacement, this model is definitely worth a try. That's it for today's video. All the models, plugins, and workflows mentioned are listed in the description. Help yourself if you're interested. See you next time.